guys, good morning. Okay, shall we start? Is everyone ready? Why is the strength so less today? Guys, will your friends join? Hello?
I don't know, sir.
Okay, generally it will be at least around 25 people, right? 20, 25 people. It's 1, 2, 3, 4, 5, only 6 are there. Okay, fine. So guys, what do you want to do? Do you want to start a new chapter? Or we have completed 3 chapters. You want to do some problems today, and maybe next class we'll start with solid states or surface chemistry. What do you want to do?
We'll do some problems, sir.
Okay, we'll do a mix of problems from all these chapters, from all these 3 chapters. Is it okay?
Okay, sir.
Cool. Right. Okay, we'll take this question. Okay. A solution containing 30 grams, a solution containing 30 grams, 30 grams of non-volatile solute, a solution containing 30 grams of non-volatile solute in 90 grams of water, 90 grams of water, has a vapor pressure of, has a vapor pressure of 2.8 kilopascal, has a vapor pressure of 2.8 kilopascal at 298 Kelvin. Right. Further, 18 grams of water is added to the solution. Further, 18 grams of water is added to the solution, and the vapor pressure becomes, 2.9 kilopascal, and the vapor pressure becomes 2.9 kilopascal. Right. So there are 2 questions. First, calculate the molecular mass of the solute. Calculate the molecular mass of the solute. And second, the vapor pressure of pure water at 298 Kelvin. Vapor pressure of pure water at 298 Kelvin. Right. So I'll repeat the question. A solution containing 30 grams of non-volatile solute in 90 grams of water has a vapor pressure of 2.8 kilopascal at 298 Kelvin. Right. So they're telling further 18 grams of water is added to the solution and the new vapor pressure is 2.9 kilopascal. Okay, they're asking you two questions. Calculate the molecular mass of the solute and the vapor pressure of water, that is pure water, at 298 Kelvin. Okay, can you do this problem? So they've given you two vapor pressures, one at some amount of water. In second case, I'm adding 18 more grams of water and the pressure becomes this much. So they're asking to find out the molecular mass of the solute and the vapor pressure of pure water, that is PA naught. So guys, I think it's just equation solving, correct? So there'll be two equations, two unknowns. You have to do something to solve the equations. That's it, right? So say for case one, right? So how many I have? I have 30 grams of water, 30 grams of solute, and I have 90 grams of water, right? So either you can use Raoult's law for this, or you can go for colligative property, relative lowering of vapor pressure. Either way, you're going to get the same answer. Okay. So if I talk about Raoult's law, so I can write it as P of H2O, that is vapor pressure of H2O after making the solution, is equal to P naught H2O into what is that mole fraction of H2O, isn't it? Into mole fraction of H2O, isn't it? This is the only equation we'll use, nothing else. So, but two times we'll use this equation because there'll be two unknowns. So in this, what are all the unknowns? Obviously, I don't know what is the pure vapor pressure of H2O, that we don't know, right? And if I go for this the mole fraction of H2O, you will easily find that it will be number of moles of H2O divided by number of moles of solute plus number of moles of H2O, isn't it? So in this, I can easily find the number of moles of H2 in both the cases because it is given, right? And in number of moles of solution, I know it is given mass divided by the molar mass of the solute, and this is the term which we don't know. So we can see there are going to be two unknowns, that is molecular mass of solute in this equation and the P naught of H2O in this equation. Both are unknowns. They're given you two times data. Do something and get these two answers. So I can just keep it as X and Y so that it will be better. Any answers? So case 1, if I substitute the equations here, so partial pressure of H2O, the new pressure which is given is 2.8 kilopascal. Okay, paste. I just stop this part. Right. So 2.8 into 10 to the power 3, that is 2.8 kilopascal, is equal to, so this I'll keep it as X. Okay, this I'll keep it as X into the mole fraction of H2O. So it is going to be 90 divided by 18. So can I say it will be 5? 90 is the given. Okay, right. So it will be 90 divided by 18 divided by 90 divided by 18 plus 30 divided by Y. Say Y is the molecular mass of the solution. Okay, Y is the molecular mass of the solution. No problem. Now this is in case 1. If I go for case 2, so in that case the pressure becomes 2.9 into 10 to the power 3 when I have 18 grams of more water getting added. So you see that the pressure is 2.9 kilopascal is equal to same thing, the partial pressure of partial pressure of pure H2O and mole fraction of water. Now what they're doing? They're adding 18 more grams of water, isn't it? So it will not be 90 grams of H2O. It will be 90 plus 18. So it will be, which will be 108 grams of H2O divided by 108.108 by 18. Again, the molecular, the given mass of solute is still the same. So it is still 30 divided by Y. That's it. So these two equations we have to solve somehow and get both the equations and get X and Y. That's it. Okay. So if I can simplify this. Okay. So 90 by 18 is 5 and 108 by 18 is 6. Okay. Fine. So I have 2.8 into 10 to the power 3, which is equal to 5 divided by 5 plus 30. Okay, X I have 5x. X is there. 5x divided by 30 by Y. And I have 2.9 into 10 to the power minus 3 is equal to, now it is 6x divided by 6x divided by 108 by 16 is 6 plus 30 by Y. Okay, this is what we have. So I think we can make it a little easy. What we can do is, can we divide these two equations? Right? If I can divide these two equations, I can easily tell that X and X gets cancelled. Or if I can rewrite this term alone, can I say it will be 5y plus 30 divided by Y, and in this case it will be 6y plus 30 divided by Y. Can I write it like this? I just take two calcium and wrote the answers from this step. Okay, so now I'll divide these two equations. Okay, let me divide these two equations. It's not minus 3, it's plus 3. Sorry. Okay, so what now will get cancelled? Y will get cancelled. X will get cancelled. Okay, so what do I have is 2 on 10 power 3, 10 power 3 gets cancelled. So it is 2.8 divided by 2.9 is equal to, so it is 5 by 5y plus 30 divided by 6 by 6y by 30. So it will become 5 by 5y plus 30 into 6y plus 30 divided by y. Okay, divided by 6. Okay, divided by 6. No problem. Okay, so I can make it actually still more simpler if you can see it. If you can see, what I can do is this 5, which is here, I can write as 1, 1, and 6. And here I can write 1, 5, and 1. If I take just 6 common out from this and 5 common out from this, okay, I'll be able to cancel this. So I have 2.8 divided by 2.9 is basically 1 by y plus 6 into y plus 5. That's it. Into y plus 5. That's what I have. All the other things are cancelled. Okay. Right. So yeah, I think I just have to. So 2.8 divided by 2.9. Say approximately I keep it as 0.9. So it's less than 1. Okay. So approximately I keep it as 0.9. Okay. So 0.9 is equal to y plus 5 divided by y plus 6. So I can write it as, if I bring this here, so there is 0.9y plus 0.9 into 6 will become 5.4 is equal to y plus 5. Right? So if I bring this here and bring this here, okay, so 1 minus 0.9 will become 0.1y is equal to, it is going to be 0.4, right? So y is going to be what? Y is the molecular mass, no? How it can be like this? There is something we did wrong. Answer cannot be 4. Y plus 6. Here I have y plus 5. That went up. 6y plus 30. Everything we did correct. 2.8 by 2.9 is 0.9. Y plus 0.9 into 6 is 5.4 is equal to y plus 5. So it will be 0.1y is equal to 0.4. There is something we are doing wrong. Guys, are you getting any answers?
Sir, I'm getting the molecular mass is equal to 4, but until
That's what. Even I'm getting molecular mass is 4, but that is not the answer.
That's not the answer.
Either the data given is wrong or whatever we are doing is wrong. Okay, I think we didn't do anything wrong. There is some problem with the question itself, right? So anyways, so like you hope you understood how we are going to do the problem, isn't it? So we have 2 equations, 2 unknowns. We are trying to solve those 2 equations. So you just have to be good at solving the equations. So if you're good at that, the answer given here is 34 grams. 34 gram per mole is what is given as the molecular mass of solute, right? But what the answer you're getting here is 4, right? So I don't know. I'll check this question, right? And then what do? You take this y value and either go to case 1 or case 2, substitute the y value and get the x value. X value is the pure vapor pressure of H2O, right? So you will be getting the pure vapor pressure of H2O as 3.4 kilopascal. So actually, the actual answer for y is 34. I don't know whether it's correct. I'm just giving whatever is given in the answer. So 34 grams and x is 3.4 kilopascal. So these 2 should be the answers you will be getting. You should be getting. I mean, I don't know. Maybe it's correct or maybe we are doing something wrong. But anyways, these 2 are the answers.
Sir,
Yeah,
I'm getting 23 for Y, sir.
23 grams you're getting for that is the molecular mass.
Yes, sir.
Okay, okay. Actually, if you can sit and do the problem little, like it takes time, you can solve it. But still, guys, I told you the gist of how to do the problem. I think you can try it later, right? If you still find problems, I'll also try. Like whenever we have time, I'll also try. So we'll see what comes out. Yeah, but still, this is how you do the problem. Very simple. Two equations, two unknowns, solve it, get the answer. Done. Okay. We'll go to the next problem. But this is a nice question, isn't it? Okay. This is the question. Take down. Calculate the amount of sodium chloride. Calculate the amount of sodium chloride which must be added to 1 kilogram of water. Which must be added to 1 kilogram of water so that the freezing point of water so that the freezing point of water is depressed by 3 Kelvin. So that the freezing point of water is depressed by 3 Kelvin. Right? So given Kf is 1.86 Kelvin kg per mole. Given Kf value is 1.86 Kelvin kg per mole. Okay, I'll repeat the question. Calculate the amount. What do they mean by amount? Are they asking about the mass? This has to be specified. Guys.
Sir,
Yeah,
could you
they're
repeat
asking
the
about the
question?
mass. Yeah, that's it. So write it as calculate the mass of sodium chloride. Right, we just wrote amount. Amount can be anything, right? So we just want, especially in terms of mass. Okay, so calculate the mass of sodium chloride which must be added to 1 kilogram of water so that the freezing point of water is depressed by 3 Kelvin and the Kf value is given as 1.86 Kelvin kg per mole. Yeah, do it.
So the freezing point of water is?
Freezing point of water is depressed by 3 Kelvin.
Okay, sir. Thank you, sir.
Yeah. Problem looks easy and it is easy, obviously. So is it just this formula? Okay, so it's like delta TF is equal to Kf into M. Is that the formula?
No, sir, it's Kf into.
Kf?
No, there is a particular formula for that. The mass of.
Okay, and it is derived from that only, right? I'm asking, is this simple that you have to substitute here and nothing else is what I'm asking. Do I have to substitute anything else? Do I have to include anything else in this equation?
Sir, no, sir.
That's the mistake everybody will do. And if you're not going to include, you are going to get 0 marks for this question if it comes in your board exams or in any of the exams. What is the mistake are we doing here? What solute is given to you?
NaCl.
Okay. So NaCl, if it dissolves in water, what will happen? If NaCl is dissolved in water, what will happen? So guys, NaCl if dissolved in water, I know undergoes dissociation. It will form Na plus ion, Cl minus ion. So whenever you have dissociation or association happening, what should you do?
Ionization.
Exactly, right? So guys, please understand, if at all the compound is given to you like this, say glucose, say urea. So these kind of solutes, if they're giving you, no problem. Directly you use the formula, right? But if they give you ionic compounds, say KCl, NaCl, like this, if they give you, like what to say, you have to use the Van factor. That is an indirect thing that it is told to you. Whenever an ionic compound is given to you, right, it is mandatory that you have to use the Van factor, right? And if at all the compounds like organic compounds or some other compounds are given to you like ammonia or glucose or say sucrose, all these things, you don't have to worry about the Van factor because there is no association, there is no dissociation. So for this particular question, the formula should be delta TF is equal to I into KF into M. This is the formula. M is the molality. Okay, fine. Next thing is, sir, how do I know the Van factor? Right, that's a good question, isn't it?
I have to write the equation.
Exactly. So the thing is, generally how I find
Percentage dissociation is not given, sir.
Exactly. That's what I'm coming to. That is what I'm coming to. Okay. So I know Na plus NaCl will give me Na plus and Cl minus, right? So what we generally how we define Van factor is basically it is the total number of moles at equilibrium, right? It is the total number of moles at equilibrium, right? So what happens is say it's 1, 0, 0. So now I have say 1 minus alpha, alpha, and alpha. So I obviously know the I value is going to be total number of moles at equilibrium. That will be 1 plus alpha. That is understood. Okay. Now, as you said, in this question, they have not given me alpha. I don't know, say if I have 100 grams of this NaCl, I don't know how much will be dissociated, right? So in all these questions, if ionic compounds are given to you, and if percentage dissociation or association is not given to you, assume that it is 100% dissociated, ideal case. Okay. So whenever these kind of questions come, ionic compounds are given, and if percentage dissociation or say the alpha value is not given, assume it to be 100% dissociated. This is how you have to do the problem. Okay. So what will be the alpha value here? If it is 100% dissociated, I know alpha value will be
1.
Exactly. So here alpha value is 1, so I value is 2. Blindly do it. Okay, right? If they give you percentage composition, I mean for percentage, yes, you have to find the alpha in I in terms of alpha and then substitute in this equation. But if they don't give you, assume it is 100% and go for the formula. That's it.
Sir, for CBSE board exam, they have cancelled Van factor. So if they give NaCl and all, should we do it
they
like
shouldn't
this,
be giving it. They shouldn't be giving it if they have cancelled Van factor, right? They shouldn't be giving any ionic compounds. But if they give, you must use the Van factor.
Okay, sir.
Okay. Okay, now it's just formula substitution.
Sir, 46.77.
Yeah, approximately correct. Answer is 47.14 or something. Yeah, no problem. Okay, so delta TF they have given it is depressed by 3 Kelvin. So 3 Kelvin, I is 2. Thus now we found out KF for water is 1.86. Modality, what data they have given? Have they given us? They have given something. How much is it? Oh, calculate the amount of sodium chloride which was added to 1 kilogram of water. Wonderful, right? So 1 kilogram of water is already given. So I just molality, how will I calculate? Number of moles of NaCl divided, they have given 1000 grams of water into 1000. So I can calculate the number of moles. So number of moles would be 3 divided by 2 into 1.8. This is the number of moles of NaCl, but I have to calculate the mass. So mass of NaCl would be this into the molecular mass. So 3 divided by 2 into 1.86. Molecular mass of NaCl is 58.5. So you should be getting the approximate answer as 47 grams if you calculate properly. Okay. Go to this question. We'll go to electrochemistry. I'm just looking for a good question. This seems to be a nice question. Okay, we'll take down the question. Okay. 1/2 cell in a galvanic cell. 1/2 cell in a galvanic cell is constructed by dipping a silver wire in a silver nitrate solution by dipping a silver wire in a silver nitrate solution of unknown concentration in a silver nitrate solution of unknown concentration, right? Its other half cell consists of zinc electrode dipped in the other half cell. Its other half cell consists of zinc electrode dipped in 1 m solution of zinc nitrate. Its other half cell consists of a zinc electrode dipped in a 1 m solution, capital M, 1 m solution of zinc nitrate. Okay, so they're telling a voltage of 1.48 volts is measured for this cell. Right? A voltage of 1.48 volts is measured for this cell. Right? They're asking, calculate the concentration of the silver nitrate solution. Calculate the concentration of the silver nitrate solution. We said it is unknown concentration, isn't it? So they're asking you to find the concentration. And they're given two values for you. They have given E naught Zn2 plus bar Zn and E naught Ag plus bar Ag. So E naught Zn2 plus bar Zn is given as minus 0.76 volts. E naught Ag plus bar Ag is given as 0. Plus 0.80 volts. So I'll repeat the question, right? So one half cell in a voltaic cell or a galvanic is constructed by dipping a silver wire in silver nitrate solution of unknown concentration. Its other half cell consists of zinc electrode dipped in a 1 m solution of zinc nitrate. A voltage of 1.48 volts is measured for this cell. So what you have to do is you have to calculate the concentration of the silver nitrate solution and have given the E naught values for zinc and aluminum. Sorry, zinc and silver. Right.
So
Go
can
for
you
it.
repeat that voltage of the cell, sir? Like 1 point?
1.48 is the voltage measured.
Okay, sir.
1.48. Yeah. So it's look like a big question, but it's very simple, right? Oh, but I think I have to use log. Let's see. So guys, like if you can use the log value and tell me the answer, or else you can just leave it at log. No problem. Yes, I think. So we'll have to go for Nernst equation, isn't it? Right? So E cell is equal to E naught cell minus 2.303. Okay, now the temperature is not given, so we can use 25 degrees Celsius. So it is 0.059 divided by N. And what are the elements used here? I think it is silver, zinc, and silver. So it is 2. Right. If at all you have problems with this, write the cathode equation, anode equation, solve it, see the number of electrons lost and gained. That should be equal. Hope you remember. Right. So it is basically one side I have basically Ag plus will get 1 electron and it forms Ag. Zinc will form Zn2 plus by leaving 2 electrons. So this will be multiplied by 2. Right. So I have 2 electron getting cancelled. So that's 2 here. So the overall equation will become Zn plus 2Ag plus gives 2Ag plus Zn2 plus. This would have been the equation, right? Okay, so 0.059 divided by 2 into log of concentration of Zn2 plus divided by concentration of Ag plus squared. So guys, if you don't do this, two things you will not be able to find. One is the number of electrons lost or gained. Second, you need to have the balanced chemical equation so that the square or cube or whatever it is, if it comes, you must be able to put it there. If you don't put it, the answer is wrong, right? Okay, so this is done. So for calculating E naught cell is only these values are given to me, isn't it? Calculating E naught of the cell, right? So E naught will be equal to E cathode minus E anode. Cathode reduction. So in reduction, what is Ag is undergoing reduction. So it is going to be 0.8 minus of zinc is getting oxidized. That comes in the anode. So which is 0.8 plus 0.76 will become 1.56 volts. Right, and they have given the E cell value also. The measured potential for this cell is also given to you. That is 1.48 is equal to 1.56 minus approximately 0.03 log of Zn2 plus concentration is given as 1m. It's 1m solution of zinc nitrate. So it is log 1 divided by concentration of Ag plus squared. That's it. Okay. Yeah.
So how are we determining the cathode anode?
Oh, that is, they have not given it, but still we know that looking at the E naught values itself, I can tell which will undergo oxidation, which will undergo reduction, isn't it? Right? So whenever you have a positive value of reduction potential, that means it will have more tendency to undergo reduction. So definitely that should be in the cathode. Right, and whenever I have lesser positive or more negative value of reduction potential, it has natural tendency to undergo oxidation. So definitely it has to be placed in the anode. That's how we decide. Understood?
Because in one of those questions we've done the reverse of it. Exactly.
But they will specify. They will specify. Right?
Oh.
If they don't specify anything, not normally what you do, that you do. Like whichever is having more positive value, cathode, less positive or negative value, anode. That's the normal way, unless and until they specify. Okay?
Yes, sir.
Right? Cool. So, yeah, so we'll this part. So, if I can bring this Ag plus up, right? If I can bring this Ag plus up, so I'll get a negative sign for log, and I can make this positive. Now minus into minus will become plus. So let me write it like this. So 1.48 is equal to 1.56. Sorry? Hello? Okay, not here. So it's plus 0.03 into log of Ag plus squared. That's it. See how I return plus here? If I bring this log up, right? So this is the formula. Log of 1 by x. I can write it as minus log x. Okay, or it's basically log 1 is 0, minus log x will become the same thing, however you do it, right? So this is done. Okay. So, or I can bring this 2 here also. So I can just rub this 2 and write 0.06 or exactly 0.059. Okay, so now I have 1 point. So minus 0.08 is equal to 0.06 log of Ag plus. So it's basically going to be minus 0.08 divided by 0.06 is equal to log of concentration of Ag plus. Okay, fine. So again, if you have the logbook, you can easily calculate this. If not, I'll give you the answer now. The answer is 1.24 into 10 to the power minus 2 m. This is the answer. Okay, how many did anyone get this answer? I mean, I think nobody would have had the logbooks with you, but still, until this point, at least you would have got. Very good. Okay, next question. So hope you've taken this down. Okay, I think this is going to be the last question for the day. And it's a good question. Okay, so take down. How long a current of 3 amperes, how long a current of 3 amperes has to be passed through a solution of, how long a current of 3 amperes has to be passed through a solution of silver nitrate, through a solution of silver nitrate to coating, COAT, to coat a metal surface, of an area 80 centimeters squared, and 0.005 mm thick. 0.005 mm thick. Right, so again, I just tell it. How long a current of 3 amperes has to be passed through a solution of silver nitrate? So obviously, we're going to extract silver from that, right? So that silver is going to be used for coating or some other metal, right? That silver is getting extracted is used for coating some other metal, and that metal surface, right? You have to coat the total area of 80 centimeters squared, and the thickness of coating should be 0.005 mm. That's the 0.005 mm thick. That should be the coating dimensions. This much area and this much thickness. Okay, fine. So they have given density of Ag. Density of silver is given. Density of Ag is 10.5 gram per centimeter cube. Density of Ag is 10.5 gram per centimeter cube. Okay. So this is Faraday's laws, but little mathematics, right?
So what is the thickness of coating?
Thickness is 0.005 mm, millimeters. So asking about the time, it should be in seconds, I guess. Yeah, it should be in seconds. So from this thickness and this area and density of this thing, you first have to calculate how much mass of Ag is required. Once you calculate how much mass of Ag is required, then you can go for the stoichiometry. Like I told you how to use Faraday's law. Right? And then find the amount of charge, the number of moles of electron, and all from these I'll be able to find the time period. So the thing is, density of Ag is given. I know density is equal to mass by volume. That is okay, right? So first I have to calculate how much volume of Ag is required, isn't it? So how much volume of Ag is required? Can I calculate it from the area and thickness? Right. So area already talks about the length and breadth, right? And obviously thickness talks about the height. So if I can multiply area and thickness, right? If I can multiply the area and the thickness, I will be getting the volume of Ag required. And if I use the density formula, I'll be able to get what will be the mass of Ag required. And then it's simple, right? See, everything is given in terms of centimeter. Please do not convert it into meters and do. Only thing you have to do is convert millimeter to centimeter. That alone you do. Okay, rest all things are fine because it's given in terms of centimeter squared. Density is given in terms of centimeter cube, right? So just convert the 0.005 mm to centimeters. That alone you take care. Rest all things are fine. Hope you know the atomic mass of Ag. Atomic mass of Ag is 108 grams. So first is volume is equal to area into the thickness. And this volume is volume of Ag, obviously. So area is given as 80 centimeters squared. Thickness is 0.005 mm. So I'll multiply this by 10 and write centimeter. Okay, because 10 mm is 1 centimeter. Correct, right? 10 mm is 1 centimeter. Right. So done. So this will be 8 times. So 8 into 0.005, which will be 40 and 3 points. So it will be 0.04 centimeter cube. Would have been the volume, right? Okay. Now density is given. Density is given as 10.5 gram per centimeter cube, and I know it's mass by volume. So mass of Ag, volume of Ag is 0.04 centimeter cube. So centimeter cube gets cancelled. So you have mass of Ag to be 10.5 into 0.04. 10.5 into 0.04, you have to calculate. So 105 into 4 is how much? 105 into 4 will be 210, 320. No, 420. Right. So 420, and I have 1.3 points. So 0.420, 0.42 grams. That's it. So I'm getting 10.5 into 4. 105 into 4. 105 into 2 is 210 into 2 again 410. 420. Right. So I have 1 point here, 2 points here. So it will become 0.42 grams. Okay. So yeah, now I have to go for the stoichiometry. Ag plus accept an electron to form Ag. Right. So I know the mass, that is 0.42 grams. And if I calculate the number of moles divided by 108 will be the number of moles for Ag formed. Right. And then, okay, if you look at the stoichiometry, 1 mole of Ag requires 1 mole of electron. So if I have this many number of moles of Ag, this many number of moles of electron, 0.42 divided by 108 is the number of moles of electron. Okay, so if I know the number of moles of electron, and then I can go for finding the actual charge of electron required. So hope you remember the formula. I have number of moles of electron is equal to given charge divided by Faraday. Isn't it? Given charge divided by Faraday. So number of moles of electron is this, that is 0.42 divided by 108, which is equal to given charge divided by Faraday is 96,500. Okay, so that I substituted. So you will be getting the charge value, given charge as 0.42 divided by 108 into 96,500. That is the charge value, right? Okay, now they are giving you, they're asking you time, right? So time is asked. So charge is equal to I into T, right? Now charge value, okay, or I can write T is equal to Q divided by I, right? So Q divided by I, so it is given as 3 amperes, isn't it? Yeah, 3 amperes. So charge is this 0.42 divided by 108 into 96,500. And what is the I value? I value is 3. That's it. Now you can calculate and get the answer. Right. So if you calculate properly, you will be getting this answer as 125.09 seconds. This would have been the answer. Yes? Did anybody get this answer? Or at least tell this much, all the steps correct?
Yes, sir.
Okay. Cool. So the answer should be 125.09, approximately 125.1 seconds. That's it. Okay. Fine. I think tomorrow or next class we'll be starting with solid state, or either solid state or surface chemistry. What do you want to start, people? You want to start with solid state or you want to start with surface chemistry? Okay,
Which
so
one
solid.
would be better if we start off with, sir?
Okay, so solid state is little full of problems, like how we are doing it. Surface chemistry will be little theoretical. There will be a lot of things to teach. So you decide. And solid state will not have much of problems. It is like, say, a lot of imaginations, because talk about the 3D orientations and 3D arrangements of atoms, solid state and all that. And surface chemistry will be studying about the surface phenomena, catalysts, different types of catalysts, and all these things.
Surface chemistry.
Surface chemistry? Okay, fine. So next class, Thursday, that is, start with surface chemistry. Okay, fine guys, until then. Yeah.
Sir, 1 minute. I sent you the solutions question paper, sir. I mean, the one which I asked you back then. You hadn't checked it yet, sir. I'd sent it long time back to your WhatsApp.
Oh, you send it for correction.
Yes, sir. Like I wasn't able to upload it in the app. So later on, after all that, you told me you just go through it and tell me what I'd done wrong.
Okay. Like, did you like the solution was given to you?
No, sir. I don't think the answer key was given.
Answer key was not given. Okay, if I'm not able to correct, at least I'll provide you the answer keys. Like that, I can provide you. Is that okay?
Okay, so that's
Can you
fine,
send
sir.
it in the group, sir?
Sorry.
Can you send it in the group?
For solutions chapter, the answer keys.
Yes, sir.
Okay, I'll ask. I have given to the epsilon management. I will ask them whether they have it, or else I'll prepare one and send it in the group. No problem. Okay.
Okay, sir. Thank you.
Okay,
Sir.
sir.
Right. And I'll try to correct a paper itself. I think it should not take much time. So I will try to correct a paper and as well as give the solutions also. Okay. Right. Cool. Thank you guys. We'll meet again on Thursday. Bye bye. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.